Hello students, today we are going to deal JEE question. We are going to write the JEE mains first exam, right? First JEE mains we are going to write. That's why I'm going to deal some JEE question in chemistry thermodynamics chapter. Let us solve all these questions. Look at this first one. For which of the following change delta H not equal to delta E? So already we know the formula delta H will be equal to delta E plus delta NGRT. So look at this. In this case, delta Ng determine whether the delta H will be equal to delta E or not equal to delta E. Delta Ng. What is delta Ng? Number of moles of gaseous products minus number of moles of gaseous reactant. So delta Ng, how we can calculate that one? Number of moles of gaseous products minus number of moles of gaseous reactant. Here the gaseous products are 2 and the gaseous reactants are 1 plus 1 again 2. So here delta Ng is 0. So the second term will be completely converted into 0 because RT and delta Ng is there as a multiplication factor. That's why the second term will be 0. In the next case, there is no gaseous reactant and product at all. That is why delta Ng for this case, is considered as 0. And here also delta Ng. Here look at this. This is solid. So you should not take this as a gaseous reactant. So gaseous reactant will be only 1 mole, gaseous product will be 1 mole, delta Ng will be 0. But in this case, delta Ng will be equal to 2 minus 4, overall minus 2. So delta H will be equal to delta E minus 2 into RT. That's why this will be the right answer. And the second thing, the reaction enthalpy, delta RH is nothing but the reaction enthalpy. For which reaction the enthalpy change will be 0, they are asking. Look at this delta reaction enthalpy, that is change in enthalpy for a reaction of which of the following reactions is 0. So look at this, whenever there is a formation at standard condition. For example, H2 gaseous state in our atmosphere is a standard condition at 273 Kelvin, 1 atmospheric pressure. That's why we can take H2 gas as a standard condition. Whenever there is a formation of a molecule or formation of ion or formation of atom in a standard state, then it will be considered 0. So for example, H2 gas at standard condition. So look at this, at standard condition, standard state formation for anything will be standard state formation. The standard state formation of anything, any molecule, any ion, any atom, anything. Standard state formation of anything will be considered as 0. So how can I say this one? H2 gas is a standard condition, right? And O2 gas is also a standard condition. So if you are forming H2 gas, then definitely the delta H for this reaction will be 0. If you are forming O2 gas, look at the standard state. I will explain here. Any standard state. H2 is a standard state. H2 gas is a standard state. So standard state molecule, standard state atom, standard state ion formation, for all that formation reaction, definitely there will be a delta H 0. So here H2 gas is a standard state and O2 gas is a standard state and N2 gas is a standard state. So whenever there is a formation of standard state, H plus H will give H2. So H2 gas is a standard state. Look at this. This one is a standard state. So standard state formation, standard state molecule formation has delta H 0 and then O plus O gives O2. Here also O2 is a standard state, right? O2 gas is a standard state. That's why delta H here also 0. And then N2 is a standard state. So N2 gas is also 0. And then look at this H, half H2 gives H plus electron. Here this H plus. Look at this H plus at aqueous condition. This H plus at aqueous condition consider as a standard state. consider as a standard state. So that is why when we are forming H plus aqueous solution from any case, H plus aqueous solution formed from the hydrogen atom, or formed from that hydrogen gas, or formed from anything. But H plus aqueous state is a standard state. So the standard state formed means definitely the delta H will be 0. That is why the reaction, which reaction we can consider the delta H as 0? Look at this here. This one will be considered as delta H 0 because H plus aqueous will be considered as a standard state. Standard state. So standard state formation of ion, that is H plus ion, and standard state formation of O2, standard state formation of N2, all will be considered as a zero enthalpy change reaction. Okay, then we will solve this one. Look at this question number 3. Delta H formation of water is minus 285.8 kilojoule per mole. Okay, so formation of water 285 they have given. Enthalpy of neutralization of mono acid of strong base they have given. Okay, that is 57.3. Actually you should memorize this value. Okay, because it's very very important, and they are asking the delta H formation of OH minus ion. First of all, I will tell you which they are asking, what are the given data. So first of all, the given data are, the third question I'm going to explain here. In this case, the given data are, clearly write the given data. It will give you a clear picture for you how to do that. It will give a clarity. So first of all, water formation. So H2 and O2 will give water, right? H2 and O2 will give water molecule. Why I am taking H2 and O2? Because these are all elemental state. Whenever you are taking the formation enthalpy, then the formation enthalpy is nothing but, that is the formation enthalpy. This is called formation enthalpy. The formation, how can I define that formation enthalpy? Elemental state molecule formed 1 mole of molecule means I can take that reaction enthalpy as a formation enthalpy. So formation enthalpy is nothing but the enthalpy change, delta H involved in, that is change in enthalpy involved in the formation of 1 mole from the elemental state. So the elemental state of hydrogen and oxygen will be H2 and O2 from the elemental state. That's why these two are elemental state. These two are elemental state. Elemental state. So elemental state, it is combining and forming 1 mole of water molecule, right? So to get that 1 mole of water molecule, we have to give only half mole of oxygen. You should not convert that into 2H2, 1 oxygen, 2H2O, like that you should not convert, because formation will be considered only for 1 molecule. So there is 1 mole, not for 2 moles. So if you are converting that fractional mole coefficient into whole number ratio, then it will be, the equation will be balanced by H2 and that is 2H2 and O2 and 2H2O. For example, you should not consider this one. 2H2 and O2 gives 2H2O could not be taken as a formation. It is not a formation enthalpy. Delta H formation enthalpy is for only 1 mole. 1 mole. So you could not take this one for this one as a reaction enthalpy. So this one is the right reaction enthalpy. So I'm going to write that one. H2 plus half O2 gaseous state gives 1 mole of H2O. Let me check what is the value they have given. It's 285.8 kilojoule per mole. So the formation enthalpy they have given us a 285.8 minus, right? Please remember that kilojoule per mole. Okay. So per mole, look at this. So this is called the formation enthalpy. The reaction I have written here, and then mono acid and mono basic solution will give a water molecule. So 1 mole of water will be produced from 1 mole of H plus, 1 mole of OH minus. So that enthalpy has been given. That is called neutralization enthalpy. That is 57.3 kilojoule per mole they have given. Okay. These are all the given data. This is about the given data. Remember here, this is given data. Okay, then what they are asking actually. They are asking OH minus formation reaction enthalpy. So OH minus will be formed from the elemental state. Whenever you are considering the formation enthalpy, then you should form that from, that is, you should form that ion or molecule, anything from the elemental state. So here O and hydrogen is there. So for oxygen, the elemental state will be O2. For hydrogen, the elemental state will be H2. But 1 mole of OH only we should form, right? So half mole of O2 and half mole of H2 please take. And then you will get OH minus, right? So here, okay, you will get OH, but we need one more electron. So for this reaction only, they are asking what is the formation enthalpy of OH minus, they are asking. Okay. So from the given data, we are going to deal with this one. So first of all, we have to get this equation from the given data. And we know that half H2 gives H plus 1 electron. So look at this. This H plus aqueous condition is a standard state. So always standard state formation. Standard state formation will be 0. So delta H for this case will be 0. Remember here. This will be very, very important. Okay, let me solve this question. So I'm going to, so this is the reaction that we need, right? So I'm going to take one reaction, the first reaction. This first reaction I'm going to take as such, because 1 by 2 O2 is in the left hand side and H2 is also in the left hand side, right? That's why I'm going to take that reaction as such. H2 plus half O2 gives 1 H2O. H2 plus half O2 gives 1 H2O. First reaction I have taken, because to get that required equation. Wait a moment, I will explain that. So and then the second equation, OH minus is in the left hand side, but I need the OH minus in the right hand side. The OH minus is in the right hand side, but here it is left hand side. That's why I'm going to reverse that too. So reverse of 2, I'm going to write reverse of 2. I'm just going to convert that reactant into product, product into reactant. That's why I will take like this. That is H2O gives H plus and OH minus, because I need the OH minus in the left, right hand side. OH minus I need in right hand side. That's why I have reversed the second equation. Okay, so I have reversed that one. After that, look at this one more thing. H plus is extra. So I have to cancel that H plus. That's why I'm going to reverse that third equation also. Because H plus is extra in the right hand side. I have to cancel that because the needed equation is not at all having H plus. That's why to cancel that one, I'm going to take reverse of 3. Then the reverse of 3 will be like this, H plus and then half H2. So when I am cancelling, that is add all this equation. First equation, second equation, third equation. I am just adding all this equation. Look at this, H2 and half H2 is there. That's why I'm going to cancel that one. Look at this, half H2 and here half H2 cancel. So the balance half H2 will be remaining. And then half O2 is there. H plus left hand side, right hand side will be cancelled. H2O left hand side, right hand side will be cancelled. The remaining part will be half H2 and half O2, and then yeah, here I didn't write the electron here, so the electron will also be there, right? This electron is there, so here one electron also there. Then finally I will get the required equation. This is our required equation. To get the required equation, what I did actually, I have taken the one first reaction as such. That's why the delta H for this one will be minus 285.8, 285.5. And then the second case, this is the reverse one, right? So delta H here will be plus 57.3. So here it will be 0, right? So how can I write this one? So for this equation, delta H formation for OH minus will be equal to minus 285 plus 285.5 plus 57.3. So finally I will get the equation like that. 2 and then 1, yeah, 57, right? So 5 7, okay, then 8 it will be, and then there will be a, okay, here there will be 7 actually. So 7 means here 2. Okay, so finally I'm getting 228.2. Let us check whether we are having that in the answer sheet. Let me check that. Yeah, we are having that one, right? 228. Actually, minus 228.85 is the right answer. Here, this is plus 228.5. So, you should be very careful on this one. Minus and plus. You should not do. That is even the simple sign change will give you the wrong answer. So you please raise your doubts. If you are having any doubt, please send your doubt in the comment section, and you can post any question. I have given my WhatsApp number. You can post any question. I will explain that one in the video. Thank you. Thank you, students.